Okay, next the question asks you about the number of orders per year. So since this is about the non-instantaneous receipt, so that the number of orders per year is also equivalent to the number of production run. Okay, so in order to calculate this, we use the annual demand. So annual demand divided by Q optimal. So annual demand in this example is 10,000, and the Q optimal or EOQ or optimal order size, they are the same. Okay, the one that we have calculated before is 2256.85. Okay, equals to 4.43. Okay, 4.43 runs or 4.43 orders. Okay, and next one, the question asks you to find the maximum inventory level. Okay, Q times 1 minus D over P. Okay, so the Q optimal is 2256.85. 1 minus the demand rate, the daily demand rate is 32.2, okay, the one that we have calculated earlier, and the production rate is 150. Goes to 1772.38, or we can say 1772. Yeah. And the last one, for the minimum total cost, okay, so it will be, okay, plus the holding cost times okay, so just substitute into the value. So ordering cost here is actually the setup cost, which is 150, okay, times the annual demand 10,000 divided by Q. Q is 2256.85, or you can just put 2257 actually, okay, and plus the holding cost 0.75 times the Q optimal, which is 2256.85 divided by 2, okay, and times with 1 minus so your total cost will be 1329.28. Example 6.7. Okay, this is the example, is a continuation from example 6.1. Okay, again about the carpet store. Okay, but here this store allow shortage. Okay, and the shortage cost is 2 ringgit per yard per year. Okay, so assuming that all the other costs remain the same, okay, all the costs and the demand remain the same, so now we want to compute the optimal order size and shortage level, and also the total cost. Okay, so for EOQ, or the Q optimal or optimal order size, okay, so again we have a different formula or slightly different formula, okay, 2 times ordering cost times the annual demand divided by the holding cost, and the whole thing you have to times with the shortage cost plus the holding cost divided by shortage cost. Divided by shortage cost is 2. Okay, and we have to take a square root of all this. So we have 2, 3, 4, 5.2. Okay, so now for the optimal shortage level, okay, this is Q optimal times, okay, the holding cost divided by holding cost plus the shortage cost. So 2, 3, 4, 5.2 times the holding cost is 2, the holding cost is 0.75, shortage cost is 2. So we have 639.6. Now for the total cost, okay, so this, because this is about the shortage, okay, we allow the shortage, so obviously the formula for total cost will be different. Okay, so the formula for total cost here is, okay, the shortage cost times optimal shortage square, okay, divided by 2 times Q plus holding cost times Q optimal minus S optimal square divided by 2 times Q and plus the ordering cost, okay, ordering cost per order times number of order per year, which is D divided by Q. Okay, so one thing that I want you to highlight here is that every time you see a Q here, this is actually referring to the Q optimal, okay, the E or Q optimal or Q prime, the one that we have calculated earlier. Okay, so substitute all the values here. 639.6 square 2 times 2345.2, okay, plus the holding cost is 0.75 times is 2345 times 2 minus the S optimal is 639.6 square divided by 2 times 2345.2, okay, plus, okay, the ordering cost is 150 times annual demand is 10,000 divided by Q optimal 2345.2. Okay, so the total cost will be, okay, so the first one, when you calculate the shortage cost is, the annual shortage cost is 174.44 for the annual holding cost, it is 465.16, and for the annual ordering cost, 639.6. Okay, the total cost for all these inventory related costs is 1279.2. Okay, so this is example, okay, about the inventory related costs. And one thing that you have to remember is that when you want to calculate, okay, anything related to inventory, so first thing you must calculate the EOQ. Okay, before you start calculating the total cost and whatsoever, please, first thing you have to calculate EOQ, or economic order quantity, or the optimal order size. Okay, the Q prime. So all these are the same. Okay, because later on in the formula you will use that EOQ, okay, for the value of Q. Okay, and the other video I will show you the example, the solution for another example.